various different bits of software, and we can crash them or break them or take ownership of them. But that's not particularly interesting unless you want to have control over a piece of software within a telco, which, to be fair, is fairly interesting. However, in terms of what we're going to be looking at is telephony attacks. It's how we can leverage the actual protocols and the actual application to do what we want to do, which is make free phone calls, impersonate other people, mischarge or misbill. Like one of the things that we found out how to do was in Florida, they've got something which allows you to pay your gas bill by telephone based on your caller ID. And because we could spoof caller ID, we could have other people pay our gas bills for us. Unfortunately, we don't know anyone who lives in Florida. Otherwise, you know, there'd be some dude out there who would get really pissed off. So, voice over IP concerns. These are the things that people worry about. And I'm going to split them up into two groups. We've got the people who actually use VoIP. These people worry about quality of service, right? Do I have to wait 6 seconds between when I say hello and when it gets to the other end? Is it going to terminate prematurely? Am I going to get drops or static, or like what's the sound quality going to be like? Is it going to have privacy, right? So can someone else listen into what I'm talking about? The quick answer is yes. The long answer is yes. Then they worry about authentication, right? Can I prove that the person calling me is who they say they are? There are protocols out there that allow you to do that. No one's implemented them, so there is no authentication. And the reason that none of these things get really, really focused on is because the people who actually provide voice over IP don't give a shit, right? They're worried about getting paid. That's their number one concern. Voice over IP security for them means, is someone going to be committing fraud? Am I going to be losing money by providing this service, right? So what they want to do is they want to ensure that their billing is secure. Once their billing is secure, maybe they worry about quality of service because that enables them to retain customers. And then, at the very end, if they've got any time or money left, they might care about privacy or authentication. But typically, they don't give a shit. They want to get paid. Right. So, specific attacks, at which point I'm expecting these guys to have internet access available for me with a cable. Do we have that? Just to my laptop, yeah. All right, never mind. So historically, the telephony attacks that were available were like exploiting the fact that the signaling in the media happened over the same line. This was the in-band stuff. Right. So specific attacks, at which point I'm expecting these guys to have internet access available for me with a cable. Do we have that? Just to my laptop, yeah. All right, never mind. So historically, the telephony attacks that were available were like exploiting the fact that the signaling in the media happened over the same line. This was the in-band stuff. So this was all of the and Steve Jobs and like Wozniak and all those other cool people used to do a whole bunch of blue boxing because the telcos were stupid. Later on, the telcos got smart and they said, wait a minute, you know, maybe we shouldn't allow end users to have access to our signaling equipment. So they separated the stuff. And then later on, in today, they said, hey, maybe we should put all of our signaling equipment on the internet. And it's got us back to square one. So what are the things that we can do against voice over IP? Well, back in the day with Phreaking, we used to be able to get free phone calls. Now we can do a lot more than just free phone calls or call monitoring. We can also do session hijacking. So we can actually take over someone's complete RTP session and start injecting our own traffic, right? This is cool. We can wait for someone to authenticate. We can then wait for them to get through any of the front-level questions at help desk, such as what's your date of birth or your social security number, and then we can inject it and say, yeah, but what's my password? All right? We can do RTP hijacking directly. As I mentioned earlier, there were several weaknesses with RTP which make it particularly vulnerable, mostly in implementation rather than in RFC definition, that make it particularly vulnerable to injection. We can also do hijacking by modifying SDP packets or sending new SDP packets, which will say to the user agents, please contact this host as well with all of your RTP streams because he wants to know what you're talking about. And thanks to the user interfaces available, no one's going to know that that's happening, right? So it's possible for a three-way conversation to get set up with the first two parties not knowing about the third party. It's also possible to do this once a session has been established by sending a new invite saying, hey, add this guy to the call. And once again, due to the way that most of these things are implemented, the re-invites go through without any notification being passed on to the user. Of course, because RTP is just over UDP and it's not encrypted, if you can sniff between the channels, so if you can get somewhere between the two user agents, you can dump all of the audio traffic out, and then the codecs are well, which makes for a great party trick. There's also spam over internet telephony. I think they came up with this name just because someone thought spit would be really cool. They haven't really thought it through. Like, I can't understand how anyone's going to make money with it. The way that people make money with spam using email is you have to click on links. If you click on links, you can go to websites. If you go to websites, they can track where you came from and who sent you the spam, and they can pay that guy money, right? Or the guy who runs the website is going to get money when you buy something. If I phone you up and say, go to this website, type in www.aaaaaqz, like, it's just not going to work, right? So that being said, there's a really, really easy way of doing a spit attack. One of the headers that's provided in the SIP RFC is called alert info. And what alert info is it's a URL to a .wav file that the end phone that's getting called is supposed to download and play as a ringtone. Okay, so this is horrible in more ways than one. There's different sorts of alert info. There's different sorts of caller ID info where you can get the remote phone to download information from the internet and display it. So you can also have it access HTML or Flash and so on and so on. Fortunately, no one's actually implemented this stuff yet. I think probably because they're lazy rather than because they're security conscious. But with a alert info header, I can point to a greetings from Nigeria.wav and send it out and have people's phones ring and then sound like they're answering and kick it in. Right. So as I said, I don't know how anyone's actually going to make money, but you can do it. Media stream injection. There's a lot of private tools out there, particularly developed by governments. I don't know why they want to do that, but they have it. MAC address. All right. So you can do monitoring, you can do injection, you can do hijacking, you can do full-on takeovers, you can do all the cool stuff that we used to have to do on IRC, you can now do to people's telephone lines. So I can't wait until someone comes out with a DDoS tool to take over, phone channels. That'll be cool. RTP stream sniffing, as I said, it's dead easy. It's over UDP. I think the first tool to come out and do this was called Vomit, and it was 2 or 3 years ago, and there was a huge outcry, like, oh my God, people can sniff. And obviously nothing was ever done about that. SIP redirection is a bit more interesting. It's a little bit more complicated than just straight sniffing. What you do with the SIP redirection is you inform one of the parties of the phone call that their proxy has now changed, and they're going to need to now start sending all of their traffic through you first. And once again, thanks to the brilliant implementations out there, no one gets notified of this. It just happens. So the software is very, very accommodating to people like us. And as I said before, you can also do third-party injection where you can add yourself as a new caller into the existing call session. There's denial of service attacks as well, but unless you really don't want someone to talk to their Auntie May, I don't know why you'd bother. Okay, so that's attacks against end users. So these are the things that end users need to worry about, which is having all of their call conversations monitored, not being able to know who's calling them, having things injected into their call streams, having their call streams getting taken over. All of the sort of voice traffic stuff that they need to worry about. What what service providers need to worry about is the fact that we can use voice over IP to misbill. We can actually commit a huge amount of toll fraud using voice over IP, and I'm going to show you guys how to do that. So you can mischarge calls. So if you can spoof calling as someone else, you can have all of the billing charged to them. And how do you spoof calling as someone else? Well, it's very simple. You change the from URI to the person that you want to have billed, right? Because the way that the SIP protocol is set up, the from header field contains a URI that's supposed to be displayed, saying, a very, very nice format of the Bob at Biloxi. Whereas the contacts header field is what is actually supposed to be contacted, right? Who you're supposed to actually talk to. So what we found when we did some work with telcos was that they were doing all of their billing and all of their authentication based on the from, and all of their software was operating based on the contacts. So we just set the from to one guy's telephone number, and then we did whatever we wanted. And we were able to spoof calls, we were able to hijack the other guy's phone number, we were able to do all sorts of stuff because everyone was worried about this from thing being correct, and no one actually bothered to check that the from and the contacts were identical. I'm afraid I don't have a slide for that, so it gets a little bit confusing just talking about it. But basically, it's very, very, very simple to do. Free phone calls, right? Free phone calls are one of the things that scares the shit out of these people because they make their money charging for phone calls. And if you're doing them for free, that's the last thing they want. So the free phone calls we can do in a couple of different ways. We're going to look at MGCP attacks, which is how we can connect directly to a media gateway and tell it to open a trunk, connect to a number, and then give us a line. And you can also do SIP attacks, where you can impersonate someone else and do the same thing. We can hijack equipment, right? These boxes that these people are buying are horrible. They're really, really bad. As I said, we found a Linux 2.2.13 box, and we could crash that with ICMP packets because they had firewalling set up that said, well, we better allow ICMP through, that might be important. And then the kernel was like, holy shit, this ICMP doesn't make sense. Abort. And that was the end of their firewall. So SIP spoofing is pretty straightforward stuff. As I said, you're in charge of sending all of your SIP packets, so you can do what you like. SIP spoofing basically involves mucking about with nothing to make sure that these two are identical in any way. Even these firewalls that we were looking at, the session border controllers didn't do any comparison. They made sure that we had a VIA in there, but they didn't bother to make sure that our SIP packet was actually sane in any way. A lot of poorly developed software out there, no one knows about this for some reason, even though it's in the RFC. So SIP spoofing, dead easy. I'll show you how to do it in a couple of seconds. Next one. Hey, a couple of seconds is up. Okay. By the way, I just got another thing from my Cellcom, and you guys are dead. Hey, all right. Okay. I'm going to use IPython for everything because IPython rocks. Okay, so VoIP is a package of Python voice over IP protocol implementations. So this tells me that from the VoIP module, import everything. I'm then going to try to see if I can remember the rest of the commands. Okay, message equals helper dots. Okay, who's got a good URI? Hopefully that's enough. Oh. Okay, so we've now created a SIP packet, which is an options packet, and we're going to be sending it to the URI of joe@google.com. We've got a VIA set up via localhost. The branch and the R port are requirements for the VIA tag. The R port as a tag at the end is going to be used for us to get information from the NAT device that we're about to hit. The from we've set to foo at bar, and the contact is bar at foo. We're going to see that this doesn't matter at all, if we're lucky. The CSEC and the max forwards, let's see, we need to change max forwards, I think. All right, so we change max forwards to 1, so we get a response back when the other guy says that it's timed out. We now need to create a socket, so import socket. I did all of this just because I wanted to burn time, actually.